Do you picture a scientist only in a white coat mixing chemicals? Today, science careers stretch from wet labs to powerful simulations on laptops. In this module, you'll see how your curiosity in physics, chemistry, maths, or biology can turn into real, impactful work in the world. When you hear science career, you might first think of becoming a doctor or a professor. But science actually opens four big families of work. One is academic and research roles, where you ask deep questions and push the boundaries of knowledge. Another is industry and applied roles, where you use science to create products, medicines, materials, or technology. A third area is education and communication, turning complex ideas into lessons, videos, or articles for others. And finally, there are support and technical roles that keep labs, hospitals, and research projects running smoothly. The right path for you depends on how you most enjoy using your curiosity. A university professor is one of the classic all-time gold careers in the knowledge world. Professors teach advanced students, guide research, and add new discoveries to a subject. To reach this level, people usually complete a PhD and often a few years of postdoctoral research. The big attraction is intellectual freedom. You explore deep questions, choose your research problems, and help shape how a whole field grows. Research and lab scientists are the people who turn big questions into actual discoveries. They design experiments, test ideas carefully, and collect data to prove what really works. You'll find them in government research centers, hospitals, universities, and private R&D labs. To thrive here, you need patience, precision in every small step, and a strong curiosity about how the world and living systems work. Think about your favorite science teacher. They probably did more than complete the syllabus. They sparked curiosity. School science teachers are all-time gold because they shape how hundreds of students feel about science every single year. In the AI era, they simplify complex ideas, connect theory to experiments, and guide students to use new tools safely and wisely. It's a career of leadership, patience, and building strong foundations for future scientists. Computational scientists are like virtual lab experts. Instead of always doing physical experiments, they use maths and code to model reality on computers. This is powerful when real experiments are too slow, expensive, or even dangerous. They work with tools like AI, Python, simulations, and supercomputers to test ideas millions of times. You'll find them in areas like drug discovery, climate and astrophysics research, and advanced virtual testing. Climate and environmental data scientists use numbers to protect the planet. They combine satellite images, weather records, and pollution data to understand storms, heat waves, floods, and long-term climate change. Using computer models, they test what-if questions for governments and companies, then turn results into clear evidence for climate policy. With rising disasters and global sustainability goals, demand for people who can read this data and guide action is exploding. Material scientists are the people who literally invent the stuff of the future. They design new metals, plastics, and smart materials that make phones faster, planes lighter, and batteries last longer. This career sits at the intersection of physics, chemistry, and engineering. You might ask, what if we change atoms in this way? What new powers do we get? AI helps test thousands of possibilities on a computer before building the best ones in real life. In science-related industries, there are three big applied roles to know. First, R&D engineers turn ideas into real products, like new shampoos, medicines, or gadgets, by running experiments and improving formulas. Second, quality control professionals act like safety guards, checking that every batch meets strict standards. Third, process development experts focus on how things are made, making production faster, cheaper, and safer, often using AI tools to optimize it. Patent analysts sit at the intersection of science, law, and business. Their main job is to study inventions and check whether they are truly new, useful, and different from what already exists. They read technical documents, compare competing ideas, and help decide if a patent should be granted or challenged. This suits students who enjoy science and detailed reading, but prefer analysis, writing, and strategy rather than doing experiments in a lab. Lab assistants and tech support staff are the practical backbone of science and technology. As a lab assistant, you help set up experiments, handle chemicals or samples carefully, and keep equipment and safety standards in check. Tech support focuses on fixing instruments and guiding users when something goes wrong. With a basic bachelor's or even a diploma, these roles offer steady, accessible entry into scientific work. Here's a fun example of how one strength can power very different careers. If you enjoy science but also love talking to people, you could become a science content creator, explaining experiments and new discoveries through videos, podcasts, or articles. Or you might go into scientific sales, helping hospitals and labs choose the right high-tech equipment. In both paths, the real superpower is the same: turning complex scientific jargon into clear, friendly human language. Think of your education path in 3 layers. First, the bachelor's degree gives you broad foundations in your subject and basic research skills. Many entry-level jobs are possible here, but you're still a generalist. A master's is where you specialize. You pick a narrower area, do deeper projects, and become more attractive for industry roles or advanced technical positions. A PhD is a long, focused, deep dive. It's usually essential if you want to be a professor or lead independent research, but not necessary for most industry careers. When you think about your future, don't start with job titles. Start with what energizes you. If you love deep theory and tough problems, you'll probably enjoy paths like academia, research, or computational roles. If you get excited by real products and experiments, look more toward industry R&D, labs, or quality and testing roles. If you're drawn to people and conversations, careers in teaching, sales, counseling, and outreach may fit better. Whatever you choose, patience and curiosity will matter more than speed or perfection. You've now seen 3 types of options in the natural sciences: long-term academic paths, cutting-edge data and climate roles, and more accessible industry and support jobs. You don't have to choose perfectly today. Just notice which group you keep looking at and which roles you feel like Googling after this lesson. That curiosity is your best first signal for what to explore next.